This is Jenny Kunkel, and in this video, we're going to take a look at what is Docker and why we would want to use Docker in this class. Let's start by addressing the first question, and that is, what is Docker? And if we look at Docker, it's an open source platform, and it's designed for building, running, and managing applications within containers. But the next obvious question is, what is a container? And a container is a lightweight, isolated environment that packages an application and its dependencies, and then it allows things to run consistently across different computing environments. Unlike virtual machines, Docker containers share the host's operating system, the OS kernel, making them far more efficient and faster. So if we would do a comparison of Docker versus virtual machines or VMs, we can see that there is going to be a resource efficiency because the containers share the same OS kernel with the host system, and therefore it doesn't need to simulate the entire hardware stack like a virtual machine. And this is going to then result in smaller resource usage, faster startup times, and the ability to run many more containers on the same hardware as compared to a virtual machine. With respect to isolation, containers are going to have strong isolation. However, they use a shared kernel, so that's going to make them lighter weight than a virtual machine, but they're not going to be completely isolated with their own dedicated OS instances like a virtual machine. So that's going to be a little bit of a difference there. With respect to portability, a Docker container can run consistently across different environments without worrying about the host OS. That means that if we spin up a container on Mac OS, it should function the same way as if we spin up a container on Windows. On the other hand, a virtual machine is going to require configuration adjustments so that it matches the host. If we look at how we can create these Docker containers, it's going to require that we use a Docker image. And we can think of a Docker image as a blueprint that's going to define what is inside that container, and this is going to include the application and any of its dependencies. And we get our Docker images from container registries, and the most famous one is going to be Docker Hub, and Docker Hub contains over 100,000 images that have been built for Docker that you can download, and this could be for databases. This could be programming languages like PHP or Perl or Python. It could be frameworks like Node.js. It could be message queues like ActiveMQ. It could be developer tools. It could be web servers like Apache or NGINX. It could be web analytic tools. It can be things for IoT and AI. It could be content management systems. There's just a plethora of things that we can download images for and spin up and play around with using Docker containers. Now, our Docker container is going to be a running instance of one of these images, and it acts like a box with everything the application needs to function already in that Docker image. We can add some configuration if we want to run with certain parameter set, and we can actually use a scripting language, which is Docker Compose, that we can script in all these parameters so that we don't have to have a really ugly long command line that we need to execute in order to make one of our Docker containers run. Now, Docker is going to combine the benefits of the isolation, the portability, and the resource efficiency. It's going to make for a more lightweight, flexible alternative to the traditional VMs. Now, if we go through and look at why we would want to use Docker for this class, it's going to simplify our setup and installation, because in a lot of cases, when we set up either a database or also some of our development environments, like if we were doing something for PHP, it involves multiple dependencies, it involves configuration and resolving some conflicts. And Docker is going to eliminate this by providing us with pre-configured container images that can run with a single command if we decide to do it that way. And it should save us some time and reduce the frustration in trying to get it to run. And additionally, after a class ends, another nice thing about that is we can easily remove the database or the programming environment if you decide that you don't want to keep it any longer by just removing the containers, removing any volumes that have been created for that container, and the images themselves. And it's easy to make that go away, and you don't have any complex situations where you're trying to uninstall software and it doesn't completely get removed from your system. And one of the ones that I think about most often with respect to this is Oracle. If you would happen to install an Oracle database locally on your computer, it's almost impossible to get everything off. However, if you spin up an Oracle container, play around with it, and then tear down the container, remove the volumes, and uninstall the image, it's totally removed from your system, and it's very easy to do. Another thing is that it also allows us that consistent environment. So if we're running on Windows, if we're running on Mac OS, we can ensure that everything is going to work pretty much seamlessly between those operating systems when we're running within a container. And the whole thing with Docker containers is they're easy to bring up, meaning that it allows us to experiment with different technologies and configurations in isolated environments without risking our main system. If we look at the support of multiple tools and technologies, we've already given the plethora of tools and technologies and languages and frameworks and IoT and AI that there are images out there that we could potentially download, play around with. So if today we were interested in running a PHP environment on an Apache server, and then tomorrow we decided that we wanted to go ahead and instead run it on a more modern web server like NGINX, we could do that by swapping out a few container images. Not a big deal. If we look at the standpoint of enabling reproducible assignments and projects, I can provide you with a starting Docker Compose file. Everybody can bring up their environments for the class, and essentially it's going to let us work in a much more harmonious manner. The other advantage is that containerization is used with either Docker or Kubernetes in the real world, and this gives you a little bit of exposure to containerization, maybe gives you a step up over somebody else that might be applying for a job because you have at least used a Docker container, you understand a little bit about what the concepts of a Docker container are and how it actually applies and is used. And if we think about the fact that if for some reason we're running a database in a class and something gets corrupted, as long as we have an image, we can always rebuild our environment really easily. So those are some of the advantages of why we would want to be using Docker for this particular class. If you have any questions at this point, please feel free to reach out to me.